Hello statistics student, this video is for chapter 8 confidence intervals, and we are looking at solving a problem of estimating mean, and we use something called a confidence interval. So this is a new concept for statistics students. What you have been doing was we say, oh, we have a population data. It's very big. We cannot collect all the data information we like to know every single one value, but we can. So what we do is we would collect a sample, right? Sample, and from this sample, so this is the big population. It could consist of a lot of data values, and this is a small sample, has a manageable number of values. We can calculate X bar. If we're measuring something, then we can calculate X bar, and then we can calculate standard deviation of that sample. For the population, it should have a mean. If we have all the data, it should have a standard deviation sigma, right? If we have all the data, but we don't, so this one, especially this one, is unknown. So in this situation, we say, how can we use X bar to estimate it? So of course, in the past, we'll say if X bar is, if the sample is a good sample is something that is randomly distributed, randomly selection, and also good size. So X bar can be used to estimate mu, right? And we call this kind of estimation a point estimate, and it's quite common. So sometimes you will see headlines that say, oh, I don't know, the weight of the population now is, the mean weight is increased 20 pounds already, or something like that. So this is estimating, but they don't measure everyone, right? So, or the mean hour of sleep for America is 7 hours, the same as 20 years ago, something like that. So that is the mean measurement. So this is, they probably use a number that is an X bar. And this is easy for people to understand. They know that, oh, we can use it to estimate the real population mean, but it's just a number. So of course this is not very accurate because it's just one number. Why is it not accurate? Because X bar is a sample. They vary. How do we know? We know X bar vary by the central limit theorem. They say it actually varies in such a way that it is normally distributed. If n is greater than 30, remember the two central limit theorem, or x is greater than, or x is normal, then your X bar actually can be any of these, right? So if you plot X bar, if you do a lot of X bar, they vary from here to here. Now, so this is what we think about. We know that our X bar is not accurate, so sometimes we would have extreme numbers. We can have one number that's really, really high, one number is really, really low. But if we use it to estimate mu, it may be far off from the real one, right? So we want to tell people that it is not so accurate, and we want to communicate with people about how accurate it is. So we will try to give a something called a estimate, interval estimate. So this is called a point estimate. So this using X bar to estimate mu is called a point estimate. In chapter 8, we are going to introduce something called an interval estimate, so that we tell people it is not, X bar is not most accurate. We actually do not know the actual mu, but it could be within this limits. So we would say X bar would be plus and minus a margin of error. You must have heard margin of error. Plus and minus E, meaning I have my X bar, but it's not the most accurate one. It could be minus E, it could be plus E. So it could be, okay, so the mean time for people that sleep is 7 hours, but it could be, half an hour error, right? Plus E, like that. So this would mean that you can say the mean is between x bar minus E, x bar plus E, if you can find the margin of error. So this is called an interval estimate. Interval. You give people an interval to tell them, mu could be any of these, not exactly this one. X bar, the point estimate, is what I have in the sample, but it could be any number. So how do they calculate the margin of error? So there's a formula, of course, to calculate it. It's all based on the fact that x bar is normally distributed. You know what is being non-significant, so this is the non-significant range of x that is going to show up. Then you know that there is a highest number and a lowest number, and because we don't know mu, we actually do not know that number, but we know how far away it is from the mean. This is the real mean. We don't know where it is, but we know E is equal to the critical value z alpha over 2, which is this one, because this is alpha divided by 2. So these two are not supposed to happen. The middle is supposed to happen, times the standard error sigma over square root n. So how do I define this alpha? So we define it by actually talks about what is confidence. So I would use red area to represent something that's not going to happen. So these are the one that is actually going to happen. We call it confidence level, C level. So most of the time, if unlikely to happen is 5%, this is 2.5%, this is 2.5%, then C level is 95%. So totally, this would have 100% when this is alpha divided by 2. Alpha is significant, unlikely value, unlikely probability. C level is likely to happen. And so this is how we define E, half of the range from mu to 1n. And this is E also. So actually E is this size. So that's why we have symmetrical, minus E and plus E. So this is the idea. The idea is when you have a sample and you want to estimate mu, you do not use just one number, the point estimate. You can give a interval estimate based on C level that you choose. You choose what is confidence that is going to show up, and then it would correspond to a alpha, which is 1 minus C level, with a tails of alpha over 2 on two sides. And this is the formula where you calculate the margin of error. And in this book, it's called EBM, error bound for mean. So we don't have to calculate by hand. We need to understand how people calculate it. But this calculation are very standard, so we use calculator to calculate it. So what's the online calculator that we use is Statistics. Okay. So I have Statistics open here. So where is it? It's under Analysis, Confidence Interval, Mean one sample. I want to do a confidence interval for mean using one sample. Okay. Confidence analysis, confidence interval, mean one sample. So when I do the example, you see how it works. So basically, you use one sample. It could be the data. It could be a summary statistic to calculate it. This explains how. That's what I talk about. That's not enough space here. This is how we talk about why we have that, and why we have that formula is because central limit theorem say x bar has a sampling distribution. So this is the discussion that we talk about. C level is something that you decide. If you are a researcher, you say, oh, I want to estimate meal. I want to estimate how many hours people sleep. So I define 90% confidence or 95% confidence. Sometimes in the homework, they would ask you to find the critical value. Remember, critical value is with a right tail of alpha, or alpha over 2 in this case, because we have the alpha on two sides. So what you do is you use inverse normal to calculate. So we'll do example on those. Let's do an example. So suppose scores on a standardized exam are normally distributed. So we're talking about a standardized exam score. We don't know the mean, but we know the standard deviation is 35. So they usually in 8.1, only in 8.1, they will give you sigma, which is the population standard deviation. Now, you might find it strange. You might say, Miss Chan, they don't even know the population mean, and where do they get this population standard deviation? Usually, this is something that they know all along. It is a standardized test, so every year how the data are spread out. They're pretty consistent, so But every test, maybe the mean is different. So, or it could be a standard deviation of IQ score. So we have a lot of old data. So these are usually from old data. So it's this population standard deviation is 35. And then you want to estimate population mean. You see how? Use the sample to estimate population means that you want to estimate mean using the sample. What happened? The sample has a 14 score. So you have 14 scores, so that's the sample size N with the sample mean of 137.3. So sample mean is X bar, right? And the sample standard deviation of 37.2. So that's S. So just be careful. There's two standard deviation here. This is for sample standard deviation. This is the population standard deviation. We use this to calculate the margin of error because the margin of errors formula is what? The alpha over 2 sigma over square root n. The standard error is sigma over square root n. And we want to calculate it at a 98% confidence level. So this is a typical question. They will tell you how confident they want to see X bar. And then from here, they use one sample to estimate the population mean. That means what is the mean score? My sample score is 137.3. And then my standard deviation is 37.2, which is different from sigma, is 35. And I have 98%, so I would identify all the information that I need. Usually in this particular sequence for statistics, we will write down C level, we write down sample size, we write down X bar, we write down S, and then most importantly, we need to use this. Because if we don't have this, in 8.2, you will run into a situation where we don't know this. And we can still do it, but we'll talk about those in 8.2. So again, we'll do statistics analysis, those that I talk about. So let's see what happened. So statistics, I'm going to click on this mean one sample, and then I'll change this to 0.98. Sample size is 14, right? Is it 14? I have 14 score, yeah. And then my sample mean is 137.3. The sample standard deviation was 37.2. And my population standard deviation is 35. It's given, right? So we evaluate. Oh, I need to do 35 first. If they tell you, you should put it in. It is not optional. If you don't know, then you don't put it in. But if you know, then you should. So I have 21.76 being the margin of error. And the mean, so in this case, it is not the sample mean, but the population mean is 115.54 and 159.06. Round to one more decimal than the original data. The original data is 1 decimal, so it should be 2 decimal. So let's go back to our notes. So you see how 115.54 and 159.06. So when we write the answer, we would write, usually we write in using symbol. We'll say mu is like this, 115.54 rounding, 159.06. If I want to do the plus and minus way, I would use 137.3, which is X bar, plus and minus the error is 21.76. And you see that if I add 21.76, it becomes this. If I minus 21.76, I got this, right? From 137.3. So this is the interval that mu would be. So my sample show 137.3, but the real mean could be 115, as low as 115.54, as high as 159. Okay, so what is the significant level and what is critical value? So significant level is alpha. So significant level are the rest of the confidence. So we say the middle is 98%. So alpha would be on the two tail add together would be 2%, right? I have 1% here,